What color is it?
Blue.
Color is green.
I was just. Yeah, the one you draw.
I pointed to the P.
So good.
We're doing like I can't even say it. Find the
Not yet. So today marks the fourth and kind of final type of factoring that we learned. So we learned about so far quadratics. We started the year, just x squared stuff, difference of squares, stuff like that. Then we went to cubes, sums and differences of cubes. And then we went to grouping, the 4-term ones where we draw the wall. And now we go to the fourth one. And then today you'll get a little bit of a taste of what's to come, not only with something new, but also that there are going to be GCFs in the problems. So the problems are going to require sometimes as many as 3 steps starting today. And then after today and tomorrow, I won't teach you anything new tomorrow, just FYI. I'll just pile more work on, but no new lesson or anything. So after this, we begin the journey now of putting it all together and getting a page with like maybe 24 problems on it or something. And there's, 3 of these and 4 of those and 2 of those. And your job now becomes to sift through and recognize, are you cubes? Are you a difference of squares? Are you grouping? Do I need a GCF? Like it all comes together like that. So you got that if you at least started on assignment 6 yesterday. If you haven't started it, you are considerably behind at this point. Just take that for what it is. In assignment 6, they were all mixed together. Like the first problem was like a difference of cubes or a sum of cubes or something like that. And then they were just, bless you, they're just all over the place. So anyways, that's where we're headed. So today we're going to first learn about Quartics. They go by several names. I don't know if you guys remember this from algebra. Do you know what a quartic is?
Nope.
I don't do a lot with vocabulary, so I wouldn't blame you if you don't remember this. A polynomial that has x squared is called a quadratic. A polynomial that has x to the 3rd is called a cubic. And a polynomial that has x to the 4th is called a quartic. And you'll actually see some quintics today, x to the 5th, but really they're actually quartics shielded underneath the greatest common factor. And I'll talk more about that when we get there. The first 3 examples are just straight up quartics, like textbook, simple, by the book. So you'll see them in math books for the rest of your life called quartics. Casually, mathematicians call them lookalikes. I'll show you what that means. And more professionally, they're called quadratic form. So they're not quadratics, but they're in the form of a quadratic. We attack them using the same mindset that we would with the quadratic. And I hope that all makes sense here in about 10 minutes. That's the goal. So let's begin with something that we already know, just to make sure that we're good. If I gave you this, I have to assume on this, the 7th day of school, that you have no issues factoring that. That is a very rudimentary quadratic trinomial, right? So if you can factor this, which we're going to do right now, then you're going to have no troubles with quartics. I just have to convince you that quartics are just like quadratics. They're lookalikes. They look just like them. So that's that. So here we go. If I said to factor this, you'd be like, yeah, whatever, light work, bore me. What would we put? X and X, because of course, this is just factoring 101. And what do I know about my signs? Positive, negative, one of each, both negative. What's the scoop? One of each wholeheartedly, because the 18 is negative. Enough said. So I can put a plus in one and I can put a minus in the other like this. Right? It's just what we did. We did this in Algebra 1. We did it last week, like light work, easy. And then we look for numbers that multiply to make 18, 6 and 3. And we put them in the correct locations so that when we add them together, we get 3x in the middle. So I would put the plus with the 6 like this and the minus with the 3 like this. It's not what you're doing today, but what you're doing today is just like that. It's very similar. So what we're going to do is we're going to take this problem and we're going to write it again. So I would write it like in my notes right next to this one so you can see sort of the whole crux of this lesson is that it's going to feel and look like a quadratic, but I'm going to buff it. I'm essentially going to take all the exponents and double them. And you'll see kind of what it looks like here in a second. So if I take all the exponents and I double them, my new problem is not x squared anymore. It's x to the 4th. And my plus 3x is now plus 3x to the double 2. And my minus 18, there are no x's, so I just leave it alone. There, for the first time in your math life, is a quadratic lookalike, or a quartic, or a quadratic form. And when you factor it, it's actually really easy if you're ready for it to be easy. What we do is we treat it just like a quadratic. We still build our shells like this. But we have to be smart and say, okay, I know that putting x in the front of each parenthesis set isn't going to work, right? Would you like to take a stab at what goes in the first 2 blanks?
X squared.
Good job. Nice leap. If I put x squared here and x squared here, I logically have created a perfect x to the 4th. And you don't want to divvy it up asymmetrically. You don't want to go heavy on one side. Like you don't want to go x to the 3rd and x to the 1st. Yes, it would make x to the 4th, but it's not going to create the symmetry that we need. So the rest of this problem is exactly the same. You see, if you haven't yet, you'll see exactly what I mean when I say it's a quadratic lookalike. Like it just flows the same. I'm just buffing my exponents is all. So I'm still going to put a plus 6. And I'm still going to put a minus 3, and I am done. Now, if you don't buy it, just go through the process and you'll see it for yourself. So like if I multiplied x squared and x squared, what do I get? X to the 4th, done. And if I multiplied 6 by negative 3, what do I get? Just like before. And you see the magic is that by splitting the x to the 4th perfectly symmetrically into 2 and 2, I've made those like terms that I need to make the 3 in the middle. So if you take this, what do you get? The green one, what do you get? Perfect. And if you take this other green one, what do you get? Negative 3x squared. And if you take 6x squareds and you take away 3x squareds, you get your 3x squared. Done. That's how you factor a quadratic lookalike. It's just a buffed quadratic. And I mean, the quadratic form is, again, professionally what it's called because it's in that even exponent, half as much exponent, no exponent format, just like it always has been. Look, even exponent, half as much exponent, no exponent. That's what it means to be in quadratic form. So having said that, that was not officially the first example. Let me run through 3 simple examples with you, and then we'll get to the ones where it gets a little bit harder. So our first official one, if I can find my note card, found it, is here. And I'd like more of your help with this one and less of me. So it's a quartic, but we're not scared because we recognize the pattern of even exponent, half as much exponent, no exponent. What do you think? How are we going to start? I love it. We're going to divvy the x to the 4th evenly into 2x squareds like that. What are my signs going to be? Plus and a minus. And what are the numbers? 5 and 3. Positive 5, negative 3, done. Put a fork in it. It's done. Next example. By the way, this can be expanded. Don't write down what I'm about to write down because it's going to be something you look at later and go, why did I write that down? But this can be expanded to like, this. Again, don't write that down, but is that in quadratic form? It is. Even exponent, half as much exponent, no exponent. So that is not a quartic, of course, that's not what we're doing today, but that is a quadratic form. Will it come to that? Eventually, but not today. So let's go and talk about the white problem and see what we do. So we're going to build our shells. What's going to go in the front of each shell? Totally. What are my signs going to be? Say again? Yeah, I just can't hear you because the air conditioner kicked on. So 1 plus and 1 minus. In any order. I get that question. Does it matter what order? Of course it doesn't, as long as there's one of each. And what numbers are we looking for? 1 and 4 for sure. And order will matter now because where we put each number will be affected by the signs. And so we know to put the plus with the 1 and the minus with the 4. Stick a fork in it. It's done. Trick question. Is it done? Correct. So this is going to be very common throughout today's assignment. You're going to need to be vigilant, hyper vigilant, to watch for, am I actually done? In the first 2 examples, I wanted to make sure we could just get the process, but now you're going to start seeing squares all over the place. X squared plus 1 is what we call a dead factor. I mean, not math, what I call it. It's got no meat on the bone. You can't go further because of the plus sign, but x squared minus 4 we recognize as a difference of squares. And so when we do our final answer here, we're going to have x squared plus 1 times something. And what are those somethings? And again, the order doesn't matter. I usually do plus before minus. I just, whatever, it doesn't matter. So that's a final answer. Let's go again. What's that? Okay, I'll switch colors and write the next example down here, kind of more in the corner.
Excuse the interruption. We need 7th graders with the last name A to J to the commons for pictures.
Just a basic look-alike, huh? I'm going to build my shells. What am I going to put in the beginnings of the shells? What are my signs going to be? Good job. Both minuses this time. Because the back number is a plus, they have to be the same. The one in the middle tells us what they are and what numbers will work. 9 and 1. Done? Or can I go further? So you telling me I can factor this one? Okay, I don't disagree. Can I factor this one? I can. So, there are no laws that say that maybe one of the factors will be then factorable. Maybe both will, maybe neither will. It is just whatever it is, it is. So we're going to go press on and make this into x plus 1 times x minus 1. So we took that original quartic polynomial and just murdered it down, bless you, to these 4 factors. Remember, these things in parentheses are nouns. They're called factors. They're like physical objects that multiply by other objects. Are we okay so far? Okay, so that's how generally you just factor a quartic or a quadratic lookalike. So I'm going to start messing with you a little bit more for these last few examples. Hopefully that part of it went well, so I don't lose you on this next part. Starting today, you're going to get your first real taste of having to do some prep work before you can actually do the problem. Like when I wrote this problem, this isn't as it is the math problem that I wanted you to do. Do you notice anything about it? There are 2. Good. So right away, we noticed that we might remember this from, it was the cubes. When we did cubes, you remember how if there was a negative in front of the first term, how we pulled it out before we could do the problem? That stays now. That doesn't go away. So that's number 1 thing that's bunk. We're going to fix that. Do you see number 2 thing that's a little fishy? Yeah, it's out of order. And that does matter when we're looking at a quadratic form, a lookalike, we want it to be very particularly scaffolded down. Biggest exponent, half exponent, no exponent. So I'm going to do a couple of things. I'm not going to skip any steps here. The first thing I'm going to do is reorganize, and I'm going to leave it as negative x to the fourth, but I'm going to switch the second and third terms to be plus 13x squared. And then the minus 36 needs to go to the back where he belongs. That's something I need you to take away from that 1 minute of our time together is your polynomials need to be in correct order. Number two is we need to do what we've done before. We need to pull the negative out. And it's not because of the 13 or the 36. They're of no concern. What concerns me is the negative in the front. And as discussed before, we don't want to factor things when they lead negative. That negative's got to come out eventually. It's part of the factoring process. Let's just get it out right now. So I'm going to take the negative, yank it out, and then in parentheses, I'm going to rebuild the whole problem. I'm not going to do the pulling the negative and the full factoring at one time. That's foolish. Negative comes out first, I rebuild, then I proceed. So we have like 2 prep steps here. So my first term is going to be positive x to the fourth. What's my second term going to be? Minus 13x squared. And what's my last term going to be? Good. Remember, pulling a negative affects everybody. It's the power of those parentheses. Everyone is affected. And now in white inside the parentheses, you now see the actual math problem that you were intended to do. It was hidden from you by some hijinks, putting things out of order and like flooding in a negative. So let's do it now. So we're going to leave the negative out where he belongs, and then we're going to build our 2 shells. And what are my shells going to lead with? What are my signs going to be? Negative and a negative. 100%. You're not looking back at this anymore, right? Don't look back. You must focus on what you create as you go. Your problem is where you are now, not where you were a minute ago, right? So the signs are needing to make a plus 36, but adding to make a negative. So they got to both be minuses. And 9 and 4 definitely come to mind. Now there's potential that this would be where we'd stop. But as per the last couple of examples, you know that that's not the case. Which factor can be factored more? Which offspring can create more offspring? Both, right? They're both differences of squares. So my final answer is going to wind up being the negative of something, 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 something. Offspring creating offspring here. What does the first one factor down into? What does the second one factor down into? And that is a fully perfect, completed factorization. The art of factoring is the art of being able to look back and say, there's nothing more I could do. There's nothing else I can break down into pieces, right? Sometimes it takes 1 step, sometimes it takes 4, like that, 4 steps. Okay. So I'm going to take that thinking that we just learned, and I'm going to take it sort of to the next level now. And I alluded to this about 10 minutes ago, that you would see some quintics today. This is a quintic polynomial, but it's not really the math problem. This is going to become the theme now for the rest of the next week or 2. The math problem I want you to do, you have no idea what it is yet, because I've taken a math problem and I sprinkled it with some mathematical nonsense. I screwed with it. I put things in a weird order. I threw a GCF in there just to mess with you. So our job is to fix it. We have to get it in the proper order. We have to get all the excess trash out, and then we can focus on the actual problem at hand. What's the first thing you notice about this? It's out of order. So I'm going to fix that always first. I mean, some of you will be hot shots and try to do multiple things at once, and you might very well be successful at that. I'm not going to, not in this setting. So I'm going to start by just putting it in the correct order. Okay. GCFing and rearranging at the same time can be a little bit of a risky business. So I'm going to take the negative x to the 5th and pull it to the front. I'm going to move the cubic term to the middle. And then I'm going to move the linear term to the back. I realize that it's not in quadratic form yet. It's not even exponent, half exponent, but that's to be determined. I need my exponents to scaffold big to small in order. Now we're ready to say, what can I do? What do they all have? This now is our battle cry for the rest of this unit. Is there one? That 3-letter thing will separate an A on the first quiz, literally an A from a D. Can I teach myself to remember to always look for the GCF? Is there one? What is it? I agree, but it's not the GCF. That is a really good CF. I should pull out an X. I'll do it right now while I've got my red pen. I like pulling out an X. It's the most X's, the greatest amount of X's that I can get out of all 3 terms. I'm with Kane on this one, is 1X, X. But what did we just talk about in the last problem? What's wrong with my problem? What is wrong with my problem? It starts with a negative. So in addition to pulling out the X, like Kane said to do, I'm also going to pull out a negative.
Can we have the rest of the 7th graders to the commons for pictures?
So I'm accomplishing 2 things. I'm fixing it by pulling the negative off the front, and I'm also pulling out the X so that it becomes a recognizable factorable entity. Get used to this. So if I pull out a negative X, I have to put a big set of parentheses now and rebuild the whole problem. What will my first term become if I rob it of its negative and one of its X's? It'll be X to the 4th. That looks familiar. Now we're seeing something we've seen before. What will plus 15X to the 3rd be?
Minus 15X squared.
Minus 15X squared. I had to change the sign and I had to drop an X.
Plus
And the last one will change to plus, and with his X gone, he is now 54. I can teach you how to factor. Like I can teach you quadratics and cubics and groupings and lookalikes, but getting that layer of crap off is really essential. And that crap can consist of a negative, it can consist of a GCF, both, whatever. But now the white problem is where we focus. So the negative X is just going to hang around now like a bad cold, like it's just going to be here. Like we can't. There it is. And then we're going to do our thing. And our thing is the white math problem. So we have shells. What goes in the fronts of the shells? X squared. Minus, minus. Thank you, Kason. I know they both have to be minuses because they multiply to make positive and add to make negative. And what are the numbers? Done, not done. Not done. Which one or both maybe? Who's factorable? Just the first one. X squared minus 6 is a trap. I wanted to maybe for you to think like, well, I can factor that, but what breaks it? Why can X squared minus 6 not be factored?
It's not negative.
6 is not a square, right? X squared is awesome. Minus is awesome, but 6 is the deal breaker. So he's like, sorry, but we do go further. The order that you put these in is irrelevant because it's multiplication, and multiplication in math is commutative, meaning you can do it in any order that floats your boat. As a matter of habit, I like to put my higher degree factors first. So when I do this, don't get confused. I'm going to write my answer in this order. I'm going to put my negative X first. Your GCF should always go first. That part we'll be bossy about. And then I'm going to take my unfactorable quadratic factor and move it to the west because I want to see it first. I feel like the pieces that we break down should conclude at the end. They should go downhill like that. So what are my last 2 pieces over here? Just like that. Okay, nothing to it, right? It's just math is just building blocks. And that's why I try to stress to you as we go, like if Monday and Tuesday didn't get figured out, you're really lost today. That's kind of how this all works as we build off of the days before. So it's imperative that you just keep asking questions. Don't let yourself get behind because one concept, sucking at one thing is going to make you suck at 5 other things. Let's go again. I have 2 more examples and then it's work time after that, okay? And I don't think you'll have any numerical GCFs today, meaning like there's not going to be numbers to pull off the front. That will come maybe tomorrow, for sure next week. You know what I mean by that? Like instead of just pulling out an X, I might have you start pulling out like a 4X or a negative 3X, but I don't think the numbers are going to come out today. So just worry about the other stuff. What's poopy thing number one? Out of order. Right, let's fix it. Relocate negative X to the fifth to the front. Relocate 8X to the third to the center. And relocate minus 16X to the back. Like that. Step 2. Pull stuff out. Right now it's a dumpster fire. That thing is an absolute disaster. What should we pull out? Negative and also X. So when I sit at home the night before a quiz and I have to write, because I do different versions for all my classes, when I write tons of problems, I start with the answers and then I sprinkle GCFs on them. That's just how I write them. Sit there and I watch a football game and I write the answer that I want you to get. And then I sprinkle it. And I might just say, if my son's over there like playing Minecraft, I'll be like, hey, Jeff, what should my GCF be? And he's like, I don't know, Dad, how about negative 2X to the fifth? And so I multiply everything. And it's just how I hide your problems from you. So get used to it. They're always going to be buried in a layer of pooey stuff. So just go find the pooey stuff, get it out, and then do the problem. If I pull out negative X, what's left? X to the fourth minus, plus 16. And there it is. There it is. That's what I started with before I sprinkled it with nonsense. So the white math problem is a quartic, a quadratic lookalike. So my answer is going to be negative X times a pair of quadratic binomial factors. X squared, minus minus. And what are the numbers? 4 and wow. Neat. Are we done? No. They can both be factored because they're the same, but they're both differences of squares. So we're actually going to wind up with an interesting answer here. We're going to have negative X times something times something times something times something. And then we're going to make it even cleaner and better. Not quite. Watch out, but you're on the right track. Now that's better. Good. We're going to have an X plus 2, X minus 2, X plus 2, X minus 2. And then we go through, and a good mathematician will always gather up scraps that are the same. Like if you're out collecting rocks, you might take all the blue ones and put them in the same jar, right? And so that's what I'm doing here is I'm going to take the things that are the same and use exponents to make it better. This is a mess. It's not wrong. It's just a mess. So my final answer should say negative X times, how many X plus 2s do I have? So I'm going to write X plus 2 squared. Neat. And then, of course, how many X minus 2s do I have? So that would be just a perfect way to give that answer. Any questions about that? You guys are doing great. All right. Oh, I ran out of board space. I got to do a new page. Last one. And then it's the rest of the hour is yours. And tomorrow you'll get a lot of no new lecture tomorrow. Okay. Tomorrow's going to be here's some more practice to do. So this will be the last time you have to sit through one of these this week. Same questions. What's wrong? It's out of order. All right, just get used to that. It's going to happen a lot. So we want the highest power term to go first. So X to the fifth says, I am the man. I will go first. I will lead the way. Who follows him? X to the third. And who follows him? Get used to that. That's called standard form. High to low exponent standard form. What do we pull out? Just an X this time. No need to pull the negative because it's already positive in the front. So I'm going to pull out just X. Zoop. And I'm going to be left with X to the fourth plus X to the 2th minus 72. And I realize I see a lot of you, I write fast. And so I don't want to be I don't want to be a jerk, but in a second here, I'm going to scroll the board up and I do that obviously because I want more room to write, but I also do it because I want you to remember And Kane almost fell into this trap a while ago. Don't look at the past. Don't look at the original problem. Don't make decisions based on this. Don't make decisions based on this. We will scroll it away, put it out of sight, out of mind, and we will focus on our new creation. That's the math problem. So we're going to have X, and then we're going to have double shells. And of course, since it's a lookalike, we're going to do this. What are my signs going to be? One of each, 100%. You betcha. And what? I said that like a Minnesotan. Yeah, you betcha. Yeah, yeah. Sorry. So what are the numbers going to be? 9 y 8. Does that work? Is that the right placement for the things? And who's factorable still?
Oh, yeah, because it's a plus.
I long for the day when you don't play my silly games with me anymore, when you don't walk into my traps. When I set my traps, it's not because I want you to fall in them. It's because I just want to train you how not to fall in them. I ask you again, who's factorable still? Nobody. And I set them both up to tempt you. I wanted this first one to look delicious because of the X squared and the 9, but then I wanted to get blown out of the water by the plus, and you go, that one's dead. And then I wanted the second one to look delicious by giving you an X squared and a minus and getting your hopes up. But 8, this is the final answer. Sometimes it is what it is, right? Any questions? Okay, cool. I shall pause, not stop the recording, and then the rest of the time today is yours. I assume you're not still working on assignment 5. You, Lord, I assume you're well into assignment 6. Assignment 7 is now posted. It's on Delta Math. So that's that. Got it?